Welcome, mathematicians! Today we're going to be finishing up our surface area of our different shapes for Math 8 for 8th grade. We've already looked at cylinders, we've looked at cones, and today we're going to be starting our look at, let's put in pink, spheres. So we're going to be looking at spheres. We're going to approach this in the same way. We're going to look at what that shape is and how we can describe it, both in our normal day-to-day language and also mathematical language. And then we're going to unravel it in a way. And then find the surface area, apply that knowledge. Today, I am going to not warn you, but I'm going to ask that if, as we scroll past these, the cylinder especially looks unfamiliar to you, go ahead, pause. Go back to that video about how we find the surface area of a cylinder, and then come back because the sphere and I will be waiting for you. Same thing goes to a cone, but today, in particular, we're going to be using the cylinder a bit. So, let's go ahead and get started on our sphere. First thing is I'm going to draw a picture of a sphere, of course. You've probably heard of another common name for our sphere, which is a ball. Yes, indeed, our sphere is just a three-dimensional sort of analog or similar shape to a circle. You've all seen things like this before. Basketballs, soccer balls, golf balls, slime balls. I don't know, that was big in 6th graders for me. And I'm going to shade this in so we can kind of see this is the middle of that ball. It's a little whatever. But that's what a sphere is. If you have that image of a ball, if you have something around you that looks like it, you know exactly what a sphere is. So that's the way we would describe it typically in our day-to-day lives. It's a ball. It's a round thing in a three-dimensional sense. But the way that we describe it mathematically is really precise. It's the same that we describe something that's a circle that's really precise. Oftentimes when I ask students to help me make a circle, as if I'd never heard that word before, that description, they tell me to make something round or curvy or something like that. But a circle is a really precise thing because not all of this stuff can be dipping in and out like it does here. What makes a circle is that it's all the same distance away from the center point. All of these radii, all this radius, means that that's the distance from any point on our circle to the center of it. That's what makes a circle special, and guess what? That's what makes a sphere special too. So I'm going to go ahead and draw the radius on here. So for example, at my radius, if I were to imagine the radius on the circle and that flat piece I drew in there, that cross section, be like this. Radius stretches out from the center of our sphere now, and also the center of that circle, all the way out to the edge. Now instead of, you might remember making circles like holding something close and drawing it on a piece of paper or something like that using a compass. But now I'm going to ask you to make that in a three-dimensional sense. Instead of being limited on the paper, imagine that you're drawing here and then you lift up the pencil and it keeps drawing. So you can draw it over, and you can draw it under, and you can draw it this way, and to the left, and to the right, and to the top and bottom, and up and down. That's our collection of points now. So they're all the same distance away from the center point, but now they can go out in any direction. That's what makes a sphere a sphere. It's a set of all points, or a collection of all points that are the same distance from a center. A good way of thinking about this, since I have my props handy, ooh, I want a good color. This is really important, orange. These are my pretzel M&Ms. I always have pretzel M&Ms as little victories when I work from home. How I keep myself sane. So, debatable. But these are really spherical. They're special M&Ms, so they're actually pretty much balls, right? They're very spherical looking. And inside in the center is a little bit of pretzel. And then you can imagine this sugar coating, this orange coating on the top, is really like the sphere. And all this orange coating is the same distance away from the center of that piece, from where the pretzel is, because there's the same amount of chocolate that coats it inside there, all the amount the same. So that's another way to think about the sphere, is it's kind of like this shell of this sort of candy. Delicious. So, now let's talk about the surface area. The surface area of a sphere, we're going to do something a little bit hand-wavy here. We're going to talk a little bit about how we can almost imagine. You might want to see, you can look up like how old globes were printed, or things like that. that might help you make an idea of it. Archimedes did a great proof of why this is true. It's a little above and beyond what I want to get into right now. Also, calculus, when you eventually meet calculus, greet him, say hello. That will also go into the proof of why this is the case. But right now I'm going to kind of ask you to hold my hand, trust me. This is a true statement that I'm going to give you right now. The surface area of a sphere, if you take all that orange coating that I'm now eating, you can actually imagine, if you unfold it in a way, peel it back like you're taking an orange and you're like peeling those pieces off of it, they can make the same shape as the surface area of a cylinder. So what I'm drawing right now is kind of like our sphere is stuck in a tube. This is a special cylinder because I'm going to ask that this is really more of a tube. The top and the bottom are open. So in this picture, you kind of imagine that this piece exists, but the top and the bottom don't. They're open, like a pipe. So the way we look at the sphere's surface area then, if you imagine unraveling the cylinder, if we scroll back up, we got two, the top, the bottom, and then this rectangular piece in here. Right now we're only looking at the rectangular piece. So let's go ahead and unravel that one more step. And it's going to look like this. So that's actually the surface area of a sphere. It's just going to have really particular dimensions, width and height in this case. So, just like before, the height is going to be this piece. And the width of this guy, all the way across, is going to go all the way around because we kind of snip this guy apart and we're going to unravel it. So just like before, as we unravel, that's going to be looking at the outside of our circle, the circumference of that circle. We know the radius of our circle is r, so let's go ahead and call that 2 pi r, the circumference of a circle. Now for the height of this guy, remember that all points on a sphere are the same distance away from the center. So I'm going to use a nice bright color like purple. And I'm going to say then right from the center to the top of this, to the edge of that tube, that's going to be r. It's on the sphere. And right down the center to the bottom of this guy is also r. So that means together, the height of this whole tube that I made, 2r, r plus r. So that means my height is 2r. Let's find our surface area. Surface area of this guy is then going to be my 2r times 2 pi r. If I multiply those two together, that wasn't the purple I wanted, 2r times 2 pi r, I get 2 times 2 is 4, pi comes along for the ride, r times r is r squared. So this right here is the surface area of a sphere. It's a pretty cool one. 4 pi r squared. Pi r squared is just the surface area, or it's just the area of a circle, and it's just 4 of those. So theoretically, if I cut out 4 circles, I should be able to paste them somehow. I might have to cut them up a little bit to completely cover a sphere with the same radius. Bizarre. So let's look at applying this guy. I'm going to scroll down here, and here's the example that we're going to focus on. Jonah needs to make a papier-mâché balloon, there we go, to make this present for his little sister's birthday. Look at that. Cute. To collect the right amount of newspaper, he needs to calculate the surface area of one balloon with a radius of 6 inches. We're going to find this surface area that he needs. So I'm noticing that we got something that we definitely need to keep in mind. I'm going to copy and paste this guy. Notice that I always know what 4 is. I always know what pi is. Radius can change. So I'm going to need this information right here. The radius of 6 inches. Let's go ahead and plug it in and see what happens. Oh, in case you don't know what papier-mâché is, this is the process of papier-mâché in a balloon. You take like light glue and you sort of paint it onto newspaper or something around something so it kind of makes a hard shell. And that's how this person is making their present, how Jonah is making his hot air balloon present for his little sister. Okay, so we have our surface area. is going to be 4 is a constant. Pi is a constant. Instead of just r, let's use the radius that's given, 6 inches squared. Evaluate. 4 times pi times 6 times 6 is 36. My best friend used to tell me that it rhymed, so it was easy to remember. And I would get mad because I don't think that 6 rhymes with 6. They're the same thing. 4 times 36. We need some side math. Oh, let's use a different color for side math. Today's side math will be in orange. Let's find what this is. 36 times 4 is, 6 times 4 is 24. 4 times 3 is 12, plus another 2 is 14. I hope that's correct. Yeah, that looks good. So our surface area is 144 pi, or I can grab my handy dandy calculator to estimate what this would be using 3.14 for pi. Remember, pi does go on irrationally, 3.14159, on and on and on. So this is just going to be an approximation. But if you were to plug it in, you would get 452 and about 2/10. Let's put on our units because we need units. So this is how much newspaper Jonah would need in order to make his present for his little sister. Alright, I hope that helps us get some understanding of how we find the surface area and how we can apply our formula, our equations to find surface area. Happy exploring. Go ahead, get your own pretzel M&Ms or other spherical things and see if you can unfold it.